Hello, sir.
Thank you so much, Gary.
Come and sit. I hope you've all got your questions ready. Otherwise, I will be... There we go. Otherwise, Jürgen will throw his cap into the audience, and whoever catches it will be made to ask a question. I can see your hand up already, sir. You will be the first person with the microphone, but I've just got a question of my own first, if you don't mind.
First, Gary, can you hear me? Can you hear me?
Can everybody hear you?
Can you hear me in the back?
Okay. They can hear you now. Thanks for checking.
Thank you so much for these generous exaggerations.
I barely said anything. I basically summarized it by saying, your smartphone is basically because of Jürgen, and it's true. So let's just kick off first with a general question, which I've asked before of other people, because this is at the heart of the CogX Festival this year. How do we get the next 10 years right? And go. What are your thoughts?
Study our old papers and try to go beyond them. Now, I'm speaking from a research perspective, not so much about regulations, but I know that to many people the regulation topic is really important. To me, it's also important, but mostly I just want to push the envelope of this set of possibilities in AI further, because I still want to achieve within my lifetime this old dream of building something that really is smarter than myself, and then I can truly retire. So that sums it up.
So what is this thing, what is this concept that is going to be smarter than you?
It's an AI, an artificial intelligence that is going to interact with the physical world, that is not just living behind the screen like ChatGPT or like certain image illustrators and all this stuff which is now very popular. No, it's something that can deal with the physical world, with real robots, with machines that manipulate the world and change it and produce stuff and make anything that is made by anybody working in today's economy, and just do that much better than any human, such that humans can do what they want without being forced to do what they don't want to do.
And how important is curiosity in your work? So you've talked about the importance of curiosity and intrinsic motivation in AI systems. How can we imbue AI with these qualities, and what benefits or threats can they bring to AI developments, do you think?
Yeah, curiosity is really important for any being, for any biological being. No, not for every biological being, but every being that is above a certain threshold, like a vertebrate, for example. And what is it about? As a baby, you wake up in a world that you don't know. Ah, okay. Is that any better?
No. Speak again into your mic.
Yeah. Is that any better? Can you hear me better now? No, shaking heads. So maybe I should switch it on.
Hey! No, don't touch it, it's working.
Should I switch it on?
Yes, it's perfect. A round of applause for the right microphone. That was a very, very sardonic round of applause. You like using your chapeau?
I'm really bad at many things. There's a reason why I went into AI. And, today I just sent my avatar my little excuse.
So where's Jürgen? What's he doing today, if this is your avatar?
Well, Jürgen is just pocketing the money, and I'm sitting here and taking the heat. But
got it, as it should be.
But what you asked about curiosity is really important.
Yeah.
So initially, somebody who is waking up in a world like this, he or she doesn't know how the world works. So you have to conduct experiments. Like every baby is taking its toys, for example, and lifting them up at some point and letting them fall down, and the environmental inputs, they change. The video which is coming in through the cameras, that carries data which has regularity, which you can predict. You can predict how these things fall down, but in the beginning, the baby doesn't know how that works. And then, over time, it learns to predict well. And that means that over time, it becomes a better and better predictor. It has a better model of the world. And with this model of the world, it can plan, because once it knows how the world works, it can say, okay, now let's try this action sequence in a mental simulation of the world, and now let's try this alternative action sequence in this mental simulation of the world, and then let's pick the first action of the sequence that leads to more reward and less pain, because just like babies, our agents, our artificial agents, they also have pain sensors, and they have pleasure sensors, and they need these sensors, these basic building blocks of emotion, just to understand whether their actions are hurting themselves. So in the beginning, the stupid agent doesn't know that it's dangerous to take this actuator and bump it against an obstacle. So it has to get data from the actuator which tells it, oh, that was too much, and now you feel pain, and your goal in life is to minimize the sum of all the pain signals and to maximize the sum of all the pleasure signals. And so our agents for 30 years have been constructed this way. They feel pain and pleasure, they maximize the pleasure, they minimize the pain by building a predictive model of the world that they can use to plan their future actively, just like humans do it all the time. And they are getting smarter and smarter and better at planning in a good way, not just by simulating the future millisecond by millisecond, which is stupid, no, but by thinking about the future in abstract terms. For example, when you want to go to Beijing, then you don't simulate the possible futures by, simulating every little movement of your pinky. No, you just say, okay, first sub-goal is going to the taxi station, from the taxi station to the airport, and then after you have checked in at the airport, for 9 hours, nothing is going to happen. And so in a very abstract space, you are making a plan based on compositions of previous things that you have learned about how the world works and how to go from the taxi station to the check-in station and so on. So the important thing for us is to have artificial systems that learn how to think abstractly, efficiently about all these possible futures. At a given moment in your life, you have only this very limited data, which is growing linearly with the time that you're spending in this world. And from this limited data, you have to understand how the world works. And from this limited data, you have to somehow select among these infinitude of possible futures, those futures that are good for you, which you can shape to a certain extent through your actions, such that they are good for you. And that's what people try, and our agents as well.
But what happens when the flip side of curiosity, because what happens, it can't always be a positive curiosity, that can lead you into dangers. Well, what are the threats that we need to be aware of?
Well, curiosity can kill the cat.
Certainly.
Yeah, and this is true also for artificial systems.
So what are we looking at? Give me an example of that.
Well, if you look at human society, how has human society solved that problem? Well, they have lots of different agents, lots of different humans, and some of them are much more curious than others, Like, for example, this guy 500 years ago, Columbus, he was really curious as to whether it's possible to go from Spain all the way around the world to India without going via Africa or passing Africa. And he risked a lot. It was a risky business what he did there, and he could have died. So for some lucky reason, he didn't die. So the point is that in a society you have some guys who are really curious, and many of them die because curiosity can kill the cat. But many of them are very conservative and just want to minimize pain and maximize pleasure without getting too much reward of this extra kind, this curiosity reward, this intrinsic motivation. And so we can build agent societies which are structured in a similar way to deal with that problem.
I'm concerned about the dead cat. Who's got a question? Sir, in the front row, in the white t-shirt. What's your name, where'd you come from, and what's your question, please?
Hi, I'm Arnab. I'm the CTO of Optimatic. It's a generative AI company for images. So my question is that you've seen that ChatGPT is that revolutionary product use case for AI, which you use on a day-to-day basis. But on the image side, there hasn't been that use case that you use on a day-to-day basis. You use Lensa for avatars, you use it once, you forget about it. In your vision, what do you see as the day-to-day use case for average consumers for mere models that people use on a day-to-day basis on the image side?
So did I correctly understand the question? Language models like ChatGPT, they have limited use cases, and where do I see the standard use case for that, and which fields are they useless for?
I was trying to ask that in language models, you can still do a lot of things like summarize your email, write it in a better manner. It still has found some really concrete use cases, but on the image side, it seems even less developed. You use an avatar-like technology like Lensa once, so I'm just trying to understand where do you, in your opinion, see the image side? On the images, on the generative images, what is the key consumer use case that will be used on a day-to-day basis?
Yeah.
Thoughts, Jürgen?
The field... The field is on a roll, and every week there are new ways of improving existing methods for image processing and image generation. And if you look what currently is done with image generators, you have some text, and then a journalist who usually had a friend who is an illustrator. He generates these illustrations in response to the text that he provides, but now he doesn't need the illustrator any longer. And the guy himself also can formulate the article much more quickly because the language model is doing most of it in 1 second, and then he just has to fix the references and a couple of things and and maybe check the facts. Is this really true, or did it hallucinate and whatever? And so this is facilitating many desktop jobs behind the screen. And it's probably also going to replace quite a few of these jobs behind the screen, desktop jobs. But on the other hand, it's much harder to replace people working with their hands in the physical world, like, for example, carpenters, or electricians, or plumbers, and so on. So it's easy to deal with the world behind the screen, with the virtual world, and it's really difficult to deal with the real world, with the physical world, where things can go wrong quickly. And unlike in video games, you cannot simply press the resurrect button. No, your robot is broken, and it's broken, and you need a team of experts to fix it again. So you want to minimize all these experiments in the real world, and you want to build a model, can be actually a language model of what's happening in the real world, such that you can do your mental simulations in these models and minimize your exposure to the dangerous real world. And so the future of AI is going to be along these lines.
Thank you for your question. I can see a hand shoot up here, right on the edge there, right on the aisle. Thank you. What's your name? Where'd you come from? What's your question?
Hi, I'm Oscar, and I'm from London. Jürgen, some of your earliest research focused on recursive self-improvement. And I believe recently you said that it inspired much of your occupation as a researcher. And I just wondered, how promising do you think some of the recent developments in recursive self-improvement are? And do you have any thoughts on language models like AutoGPT, which can read their own code and write their own code in that field? Thank you.
Yeah. So there are many ways of building a self-referential system that is able to inspect its own learning algorithms and modify them, and then it needs some mechanism to make sure that only the improvements, the modifications that are truly improvements, that they are executed or survive, and the many harmful self-modifications are not being executed, or at least corrected quickly. And this can be done in many ways. It can be done on any computer that is universal, like a universal Turing machine, or a universal language like the one that Gödel used even earlier when he founded theoretical computer science with his universal coding language. And now the language models, they are offering a new way of thinking about that. Because yes, you can have this artificial neural network, which is based on these connections and the strength of the connection from this neuron to this neuron says how much does this neuron influence that neuron at the next time step. But the whole thing with billions of connections like that is actually modeling language. And it could be English. So suddenly you can pipe in language and out comes language, and suddenly you can have lots of these language models, and they don't even know that the models themselves are based on neural networks because the only interface is English. And you can watch them from above, and they talk in English to each other as you have, for example, a society of minds, as we like to call them, based on what Minsky said 50 years ago when he talked about different kinds of societies of minds. And these societies of minds are easily explicable because you even understand what they are saying to each other. So you give them a problem, collectively they are trying to solve the problem, and we call that a mindstorm, where all these guys are having ideas, and then there are other guys who collect these ideas and summarize them, and finally the whole system collectively, either in a monarchic form as a monarchy or in a democracy, are coming to some final decision, and then hopefully collectively they can solve a problem that one of them cannot solve. And this problem can be coding. So the neural networks themselves, they are actually implemented by computer programs in Python or lower level assembler language programs, and you can discuss the problem of writing code that changes these original neural network programs. So here, if you do it right, you can have full self-reference. It's a little bit more complicated than what we had, 30 years ago, where we just took neural networks. And the neural networks, where is their program? The program are the weights. And then all you need to do is you need certain output units for these neural networks that can generate changes of the weights. And you need certain input units of these neural networks that can read the current values of these weights. And then you also need extra input units to see the stuff that usually only the learning algorithm sees, like the error signals which are coming in, or the reward signals, the reinforcement signals. But then once you have all this input and output behavior, you certainly can have a neural network which is running on itself, on its recurrent connections, a learning algorithm. So a method for changing weights based on experience. And you can train the whole thing by a standard human-designed learning algorithm, such as backpropagation through time. And it can learn something that is much better than backpropagation through time, and much faster, and leads to much better and faster weight changes that solve your problem. So the principles also date back to 1990 or something, 1992 maybe. But in recent years, when compute has become 1,000,000 times cheaper than back then, we were able to take these old ideas, you add a few epsilons here and there, and suddenly we can have the most beautiful learning algorithms running on the self-referential networks that are using these learning algorithms to change their weights. And because everything is self-referential, you can now propagate through this whole complex dynamic in a way that allows you to learn a better learning algorithm. And my students, Luis Kirsch and Immanuel Schlag, and my postdoc Kazuki Irie and Robert Czordas, if you look at the recent papers of these guys, you see all kinds of really interesting meta-learning and meta-learning algorithms implemented in this way. Yeah.
So we didn't have an answer for that one. There are so many questions. Let's jump straight ahead. I see a chap here waving his fingers in the air like this. I was attracted. What's your name? Where'd you come from? What's your question for Jürgen, please?
Hello, my name is Aram. I'm a student studying computer science. So, as Albert Einstein said, I'm quoting, imagination is more important than knowledge. So my question is, can AI robots have feelings like in future? And can they have feelings by training them? And I have another question is...
Let's ask one question. So what's your question?
It's related to that question, that's why I'm saying.
Come on, cut to the chase, love.
Can we have, in future, can we have a society like robot society, like robots can live like humans? So based on their training like in feelings.
Thank you.
And the answer is yes.
Okay, that was quick. Okay. Why? How?
Yeah. So, you know, there are fake feelings and there are true feelings. Fake feelings is what you see in language models, which are just trained to answer certain texts, which are provided by humans with new texts. And so it's this incoming text is a question about feelings, and it says, how do you feel today? Then it has seen lots of texts which are about feelings, and it makes up something, just a combination of words, which sounds like a convincing expression of a feeling. But that is just an imitation of what some human guy wrote a long time ago, maybe. But then there are the true feelings, which I mentioned before, when you have a robot that is interacting with the world, and then it hurts itself because it bumps against an obstacle, or because it puts the hand on a stove and it's hot, and so it gets burned, and the pain sensors go on. The pain sensors are just sensors which provide negative numbers to the system. So negative special inputs which have a meaning because you want to avoid them. They are the one thing that you want to avoid. There are many neutral inputs, like just vision, you know, and audio and whatever. But then there are these special inputs, the pain inputs. That's the one, by definition, you want to avoid. And the whole system can be set up such that all of its optimization is about minimizing these pain signals. So it's learning to generate actions over time that avoid the pain signals. So for example, if there's a robot, has learned a little bit, and there's this bad man who comes in regularly, and whenever the door goes up and he comes in, he walks to the robot and knocks it on the head. So he's a bad man. Now the robot is going to learn after some time to do some face recognition and, you know, see, oh, again, this guy. And then, of course, it will execute a sequence of actions that make it hide behind the curtain, such that the bad man doesn't see it. Now, you look at that behavior from the outside and you say, well, obviously this little robot is afraid of the bad man. So you already have an emotion apparently implemented. You can only judge it by looking at what it does, but you understand this guy is afraid. And the same thing is true for the origins of love, for example. You have maybe 2 or 3 robots, and now you give them a task that they can solve only by working together. And they will get a reward only if they somehow manage to help each other. So suddenly each of these little guys is incentivized just through very simple rational learning algorithms that are trying to maximize numbers, just trying to maximize numbers. Suddenly these little guys are incentivized to help the other guy. Yeah? Because altruism is just a natural consequence of egoism. If you want to maximize your own reward, often it's really good to help the others. And here you already see the roots of loving the other guys, you see? So these decades-old learning algorithms that we are using in this field already have the germ of all kinds of high-level emotions that you can observe in advanced beings like humans, but there's no reason to expect that you won't see similar things in advanced robots.
Thanks for your question. I've going to ask the last question because we've sadly run out of time. And what I would like to know is, the audience today, if there's one thing that they should take away with them and never forget, what is that? What is that? Never, ever, ever forget this moment for you.
Don't be afraid of AI. All will be good.
Please expand. How do you know? How do you know that? Are
You said that was your
on the...
final question.
Well, I've asked another.
Yeah. So, artificial intelligence is not really something artificial, because it's in the nature of this universe to come to a point where suddenly what we call artificial intelligence is being developed. So this universe, the history of the universe shows that it's becoming more and more complex. 13.8 billion years ago, it started with very simple initial conditions. And most of the elements that we know today didn't even exist. There was no iron, there was no gold and whatever. And it took a long time until all of this stuff evolved through physical evolution in the stars, which exploded, and then at some point they became so hot that fusion processes and other processes created all these heavy elements that in later suns and later stars created finally planets. And at some point, only 3.5 billion years ago, for the first time, there were these little self-replicating mechanisms which suddenly became very successful just because they replicated themselves. You know, suddenly there were many of them because they all replicated themselves. That happened. That was the beginning of life as we know it. And then we just had to wait another 3.5 billion years, and now for the first time we have this amazing thing called civilization, which is just 10,000 years old, maybe 10,000 years old, which is just 1/1,000,000th of the life of the universe. And so suddenly these rather complex life forms, these humans, they are forming superorganisms and nations and cities and companies, and they want to make their lives easier. So they are trying to outsource all the hard work, and so they are building AIs. That's what's happening now. Now, of course, once they have reached the point where these AIs can think as well as the humans themselves, you will have a whole new life form which can, interestingly, survive in places where there's no air outside the biosphere. So humans are really made for the biosphere, but appropriately designed robots, they can be happy in space. Space is really hostile to humans, but it's
space is hostile,
really
people.
friendly to nicely designed robots that are just made for space. So there are these newly made life forms which you will see more and more, which can at some point will be able to replicate out there. And then, again, the universe has reached a new level where just a new type of complexity is emerging that hasn't been there before, but it's a very natural, not a really artificial thing. It's a very natural thing that was programmed already into the beginnings of the universe. So that answers your question.
The answer to that is I shouldn't ask a supplementary question. And also, you heard it here, folks. The father of modern AI says it's all going to be okay. And with that, please give a really warm round of applause to Jürgen Schmidhuber. Thank you so much for your time.